Alright, in this video, the objective is to be able to represent, analyze, and solve permutations. And if you remember, permutations is where you're choosing a set from a larger set and the order matters, or if the order is different, that's a different set of outcomes. So let's say that let's get some notation here. Sometimes you will see permutations written NPR, and the N will be a number, and the P stands for permutation. When we get the combination, that will be a C, and then the R is another number. So we're saying that out of, this is the number of choices, or out of this many total options here, we're choosing this many, the R, whatever the R value is. So the number we're choosing. Okay, so for example, here's an example. You have a CD and it has, there's 10 songs in the CD. You want to know how many different ways can you play the first 3 songs, or if you push shuffle on your CD player, then how many different options are there that you could play, that the first 3 songs will come in. So in order to do that, we have 10, and then so also this can also be solved by doing n factorial and then n minus r factorial and then simplifying that. So there's 10 songs, so that's going to be 10 factorial, and then we are choosing 3 songs out of there, so it's going to be 10 factorial over 10 minus 3 factorial. Now in order to simplify this, 10 factorial, well, let's do this. 10 minus 3 is 7. We solve parentheses first. So that equals 7 factorial. We know that 7 factorial is 7 times 6 times 5 times 4. We don't have to write all that out. 10 factorial is 10 times 9 times 8 times 7 times 6 times 5. But we can just write at this point that factorial there. Okay? So if you see, great. If we were to write out 7 times 6 times 5 times 4 times 3 times 2 times 1, and this 7 times, all of those would end up canceling. So we can, at this point, just cancel the 7 factorials. Okay? And then we're left with 10 times 9 times 8 over 1, which just makes it a whole number. So 10 times 9 is 90. 90 times 8 is 720. So out of a 10 songs on a CD, you could play, and you push shuffle, there would be 720 different ways that you could play the first 3 songs on that CD, or the order of the 3 songs would be. Okay, let's try another one. Hey, Alyssa, do you have a question for me?
Hey, what about?
What are you doing here?
What about if it's 4 letter codes, and you can only have 4 letters, and you can't repeat any of the letters? What would that look like?
Well, I'm glad you asked. Well, so if you had 4 letter codes, well, why don't you solve this one? If I said you're going to have a 4-letter code combination, maybe you're picking a security code for what's that thing we used to do, Mathletics or something like this, and you're picking, you have 4 letters to choose from, and none of the letters can repeat. How many different letter codes could you have? You know how to solve that?
Yeah. So there's 26 letters in the alphabet, and then 4 positive numbers, letters, and you could write that as 26 factorial over 26 minus 4, and then factorial. 26 minus 4 is 22 factorial. And up here we have 26 times 25, 24 times 23 times 22, and so on. These 2 cancel. And
there you go. Can you see? Look. There you go. All right, now you can.
And 26, 25, 24 is 3, 5.
Wow, are you doing that in your head?
Yeah.
Wow, that's amazing.
8 and 0, 0.
Wow, you're right.
Yeah.
That's pretty good.
It,
Well, if you guys at home can't do that in your head, you can always use your calculator. All right, now I got one more question for you, Alyssa. Let's say out of a class of 13 students, how many different ways can you have, can you arrange the class officers to have a president, a vice president, a secretary, and a treasurer?
Well, there are 13 students, right?
13 students.
13, B, and then there's 4, like that.
Mm-hmm.
And yep. And right. And you could. Okay, I don't know how to explain this one.
Okay, well, the important thing that you need to recognize here is that even though we're not saying there's going to be a first and a second and third, we are saying that there's a president, a vice president, a secretary, and a treasurer. Let's say, for example, right?
But wait, does the order matter in this one?
I'm glad you asked. It does. It does. Because if for example, if Billy Bob is the president and Susie Q is the vice president, and let's say Victoria is the secretary and Cletus is the treasurer, right? That is different from Victoria being the president and Billy Bob being the secretary. So in this case, we're not saying that it's just a random, what are the chances of 4 people being class officers. We're saying that the president and the vice president, secretary, and treasurer, those are different positions. And so yes, the order would matter. So we use a permutation.
Mm-hmm. So this can also be written as 13 factorial over parentheses 13 minus 4 factorial, which is 13 minus 4 is
9.
9,
You
right?
did that math.
9 factorial, and then 13 times 12 is 11 times 10 times 9 and so on. Factorial. Cancel. These are
Make sure they can see.
alright, like this, and 13, 12 is like 15.
Alright, there you go.
4, 0? Is that it? No, it doesn't have 4. I forgot that one.
Okay.
It happens with mental
It
math.
happens with mental math. When you try to do that in your head. 154,440. Okay, so that is the number of different ways that you could have a president, vice president, treasurer, and secretary out of a class of 13 students. That's a lot of different options there.
Yep.
Okay, so as always, I hope that made sense. I'd like to thank my special guest, Alyssa, for helping me. And hopefully you guys not only found it entertaining, but educational as well. Thank you for watching.